Hi, I'm Aaron Hand. I'm out at the SPIE BACUS Photomask Technology Symposium in Monterey, California, where I was able to catch up with a few of the panelists from the MCA BrightSpots Lithography Forum. These industry all-stars had a lot to say about advanced lithography, and here's a bit of what they had to talk about. I am here with Aki Fujimura, who is Chief Executive Officer of D2S and Managing Sponsor of eBeam Initiative. Aki, the eBeam Initiative announced last week several new members. Can you tell me a bit about what they bring to the party?
Yes, there are 4 new companies that's joining the eBeam initiative. Equicon, who is a German software maker. They work in particular with a tool called Vistec Corporation. Tool Company, which is a Japanese company. They also specialize in software in the back end. And Synopsys, who I think everybody knows is a large company, but in particular in our space, they have the CATS franchise for conventional fracturing. And A-Beam Technology, which is a US-based company that is specialized in very esoteric simulation of E-beam effects.
Okay. So I understand the eBeam Initiative is presenting collaboratively at the Photomask Symposium on some recent results. Can you tell me a bit more about that?
Yeah, there are several announcements today and also tomorrow at the BACUS conference this week. The basic premise of what we are working on right now is that mask writing times are becoming a very, very huge issue, particularly in 20 nanometer, as we predict coming along in the next couple of years. And one of the issues is that because writing 193 nanometer, using 193 nanometer light to write 20 nanometer node features, which are, let's say, 50 nanometer to 60 nanometer wide, is very, very difficult. It's like trying to write a 60 nanometer dot with 193 nanometer brush. Right? It's very difficult. But it's possible to do that. But how you make it happen is that the masks have to be very, very complex. So there's this trade-off that would have to be made between getting good wafer quality and getting good mask quality. But of course, you need to have both a good mask and a good wafer to make a good chip. So how can we resolve that problem? And one of the set of announcements that we're making is about model-based MDP, or MB-MDP for short. And this is a mechanism by which we can take advantage of a new set of capabilities to overlap shots and also to do dose modulation and also to be able to use any kind of a shape, not just the traditional VSB or variable shape beam rectangular shots. And being able to do all of those things together, we can, in particular, use circular apertures, which have been announced by the JEOL Corporation, to be able to shoot curvilinear assist features and circular main features with much better write times, actually 30% reduced write times, than conventional fracturing would take on Manhattanized masks. So this results that's being announced, actually was announced this morning, is further reduction of that to the write time 25% reduced on top of that 30%. This afternoon, we'll be talking a little bit about doing a reduction using Manhattanized masks using only conventional VSP shots. So it's nice to have the circular apertures, and there are many good features about that. But conventional machines today that's out installed in the mask shops do not have this capability. So the announcement is about being able to use this technique also for VSP rectangular shots that everybody has in their mask shops today.
Okay. Well, thank you. It'll be interesting to hear more about these various technologies that eBeam Initiative is talking about. Thank you for joining us today.
Thank you.
I'd like to thank the panelists from the MCA BrightSpots Lithography Forum for their time and comments. I hope you'll join these experts in an online discussion beginning September 15th and running through September 22nd. I'm Aaron Hand with the MCA BrightSpots Lithography Forum.